Hello, everyone. I'm gonna explain and elaborate our last paper entitled Cross-lingual NLU, Mitigating Language-Specific Impact in Embeddings, Leveraging the Adversarial Technique. This paper has been accepted in the ERRE calling 2004, which will be held in the Torino in Italy. I would like to begin with the introducing our authors. I'm honored to introduce this Saeed Tahiri. Is a PhD student of the computer science of the KNTU University in Iran. Sahar Kianian she is a assistant professor of the Shahid Rajaei Teacher Training University in Iran, and me. Uh, I am also the assistant professor of the KNTU University and AI researcher in the Fondesino Bruno Kessler in Italy. Okay, let me first start with the problem definition. What we claim is we claim that the embedding the contextual representation that provide us with a large language model, BERT and MBERT, for example, at least contains two sort of information. The first one, which is the important one, is a semantic information. Semantic information refers to the meaning of the text. But the second one, which is called the language-specific information or the linguistic information, is the information of the language that we used in order to produce the text. Okay, for cross-lingual technique, for cross-lingual tags, we want to use the benefit of if we want to use the benefit of the high resource languages to make a model in for low resource languages, we don't need the language specific information. It would be a good idea if we find a way to mitigate this kind of information from the embedding that produce us with a large language model. So ultimate goal is removing the language specific information without compromising the semantic information of the embedding. We use the natural language understanding as our downstream tags. We know that NLU is the pivotal module of the task-oriented dialogue systems. It's the first module that is given by the utterance of the user and try to recognize the intent and the slot. Actually, two important tasks in NLP has been done in this module. First is intent detection, which is recognized as the classification task, and the slide filling, which is recognized as sequential classification task. Both of them are very important. Here I have an example in order to explain it more. What is the weather today? It's a trans, and this module try to detect the intent, weather, and the slot, date and time, and another slot is weather, and its value is I try to fill this slide with its values today and weather. Okay, let's go. We know that the major challenge we come to the low resource languages is labeled data. We know the machine learning techniques needs the label data in order to do some fine-tuning. But in the low resource languages, we don't have this data. In the dialogue system, task-oriented dialogue system, producing and generating the label data is considered a very time-consuming and cost us lots of fortune. So we try to find another way in the cross-lingual manner in order to address this problem. Let me go through our proposed model. For simplicity, I want to elaborate first the adversarial part of our model, and incrementally I add the tasks, I mean this slot filling and the intent detection, and explain it more. Here you can see that has a two part. The first one, we use the embed in order to produce us the contextual embedding, and this contextual embedding is fed to the second part, I mean the adversarial part, into the generator in order to produce the generator produce the shared representation. Here in the adversarial part, we have two important actors. First one, generator. Its duty is the generating the shared representative, and second one is a discriminator. Its main duty is to recognize the language ID. As an input, we have a sentence in English and sentence in Spanish. In this adversarial part, generator and discriminator trying to undo each other, actually, because we know that the discriminator, if they recognize correctly the language of the input, it's because of some language specific information that here in the represent that it is available here in the language, in the shared representation. If the discriminator doesn't succeed to recognize and distinguish the language, it tells us that the language specific information is being reduced, is being mitigated. Here in generator, we use just simple BiLSTM and in 2 layers. And here we use the MLP, multi-layer perceptron. In terms of the way and number of the parameters, we know that embed all the layers are frozen, so we have less than 7 million parameters. It's lightweight, actually. Here another thing, the last thing that I want to say is the loss function. Loss function as a discriminator, of course, used in order to train the layer of the discriminator and make a contribution in order to form and calculate the total loss. This total loss is accumulated by the loss of the task and provided to the generator in order to train the layers of the generator and teach the generator how to produce representation, has lots of information about the task, but mitigate the language dependent, language specific information. Here we add another module. It's a slot filling module, of course, has its own layer, task specific layer, produce the loss function. A loss function use the in order to train the specific layer, and use with a coefficient used for the computing the total loss. We do the same for intent detection, a specific layer, loss function used for a specific layer, and with a coefficient of beta, multiplied in the coefficient of beta, and make a contribution to compute the total loss. In this slide, you can see the formula of the total loss. This is very important. Alpha multiply that loss of the slot filling, beta multiply that intent minus, because we know that we don't like this kind of the loss, and lambda multiply the loss of the loss generated by the discriminator. We know that in this adversarial manner, two component, I mean the generator and discriminator, interact adversarially and try to undo each other. During the process, I mean the competitive process, when unfold the language, hopefully language specific information in the embedding, in the initial embedding, gradually gets mitigated. Let's see a little bit about the convergence. I know this implies us a lot of information about the how the training process continues and unfold. Although we here in this picture we see that all the loss function decrease, but the loss function of the discriminator increase. Actually, the readout we don't want to, we're not expected to see the increasing in the increasing in the loss value of the discriminator. The discriminator here in this curve shows that the discriminator performs well in initial steps, but gradually encounter some challenges in order to recognize the language identity. It implies that the language's specific information during the training is being mitigated. It's very good news for us. Let's a little bit explain about the experimental study. We use the Facebook multilingual dataset. Is considered as a standard dataset for the multilingual tasks. We use the three languages: English, Spanish, and Thai. And three domains: alarm and reminder and weather, and 12 intense and 11 slots type. And also, in order to complete our experimental study, we use Italian and Persian. We have to be aware that the Italian and Persian is generated by have been generated by the Google Translation, automatic translation, and alignment in order to find the slots and intents actually. The result we achieve are depicted here. We have a two important bar chart. The right side that shows the performance of our system in the slot filling, the left child intent detection. The blue bars shows the performance of the supervised learning, and the zero shot. This is where I like doing this kind of our work, because we know we want to use the in the cross-lingual manner. Zero shots indicates depicts by the red bars. You can see in slot filling the performance of Spanish is acceptable, but we can say that for Italian and Persian and Thai, especially for Persian and Thai. But in intent detection, all of them are good enough and actually is acceptable. Let's draw some conclusion. You know that we have we try to experiment examine the performance of our model in the Latin and non-Latin languages. Although the performance in the zero-shot scenario in the Latin languages, such as Spanish, considers good, but we know that for non-Latin languages such as Thai, we haven't seen a good result. We haven't achieved a good result. Our speculation is the first speculation is that because of the distortion in the embedding generated by the multilingual by the language model. Actually, we know that the discriminator heavily rely on the quality of the initial representation. When the quality is not good, the whole of the system, especially discriminator, doesn't perform well. Okay. Let me tell you a little bit about the future work. The important question that we leave this left this question for future work is during this process. I mean, when the process is running, and how much data of the um, semantic part has been lost. This is very important. We know we can conduct some other experiments and modify our model in order to minimize the impact of our adversarial part of our model in the semantic part of the information of the embedding. Okay, at the end, I should be grateful of the organizer of the calling and ERIC and calling 2004 to provide us this opportunity to explain our work. Thank you. Goodbye.